Hello everybody, thank you for attending to my presentation for this special doctoral students week. I'm going to present you what I've been doing during my first year of PhD. I'm doing a PhD about diversification of tetrapods in neotropics, but I will focus this presentation on what we can learn from phylogenies about extinction and paleodiversity dynamics. So estimating paleodiversity dynamics is a major challenge for macroevolution, and we can address this question with fossils and with phylogenies. Fossils have been used a lot in the field for this question, but there are still some limits because it needs a lot of fieldwork to get a large sampling size, and not all groups fossilize very well, especially in the tropics. And phylogenies are more and more used since the development of diversification models that allows to estimate the probability that the lineage splits into two lineages, that the speciation rate, and the probability that a lineage goes extinct by million year, which is the extinction rate. Of course, there are some limits, and the main one is that extinct species are missing in most of the case, so the number of lineages through time increase artificially. Sometimes recent radiations can also hide past extinction and create too much heterogeneity of diversification rate within the same tree. And by taking into account this heterogeneity, Elmore and some colleagues reconcile molecular phylogenies with the fossil record, and they apply this to the Cetacean phylogeny. So how does it work? When you apply a single model of diversification to two different topologies but with the same branching patterns, meaning the same distribution of node ages, the likelihood will be equivalent, and that's not the case when you apply models of diversification to different parts of the tree. You will take topology into account. So what they did by hand is to select some clades thanks to taxonomy. The rest of the tree is called the backbone. Then they applied diversification model to them, and they expect to have a backbone with an extinction signal, which sometimes could be higher than the speciation rate. So the net diversification is globally negative on one of the part of the tree, and then you can sum up the different ACC to have a global ACC and to compare it to other combinations with one shift, two shift, three shift, etc. to select the best ones. The main problem is that it's very costly, and you miss some by doing, if you do that by hand, and you miss some nodes that are testable just by merging subgroups. So what I did is to automate this method to test all combinations, and I'm going to show you some preliminary results. So I had to start from taxonomic database, and thanks to a script that I developed, I've been capable of gathering some taxonomic groups and to test 23 nodes in this phylogeny of the cetacean. This creates 1,326 combination tests. So of course I developed another function who applies different diversification model to each part of all combinations and compare them side by side. So we can compare the result we have with the result from Malone on the left, and actually there are only two branches that are different, not in the same part of the tree, between the combination and the best one we selected from the 1,326 we tested. Then in terms of diversity trajectory, the trajectory estimated from Malone and Hall is on the left, and the ones we selected, the 15 best ones, are on the right. And there is the same tendency, the same diversity dynamics, with a decrease around 10 to 15 million years ago. But we explore many other scenarios, which is very interesting. Actually, the DAG scenario is the 14 scenario, and has the same number, actually is quite close in terms of diversity than the best ones we selected. But if you look more carefully, we estimated twice as many species as they estimated, and this is probably because the stems, which are the root edges of subclades, have been included in the backbone. So because we expect that they bear extinction signal too, maybe we better estimate extinction here. So in terms of perspective and complementary work, I recently set up some simulation. We're gonna apply this to many different groups to see what we can learn from them, and we want also to implement this on the package AirPanda in R to make it more friendly user to everybody. Thank you for your attention, and sorry if I've been a bit long.